Oleksii, the floor is yours.
Yeah, thank you for the introduction, and thank you everyone for coming today here. So my topic is about simulation modeling of a mission system in Ukraine. And first, I would like to start by opening another slide. Sorry. Yes, I'd like to start with acknowledging my supervisors who really helped me greatly in all this work, which are Oleksii Ignatenko and Severyn-Dmytro, who really helped me to shape my vision of what this topic and project will be. At one of the talk, we will start with the introduction, move on to the motivation and research goals, then on the outcomes of the related work analysis, which we've done during all this, visit, identify research gaps, analyze the research questions and the result research problem, talk about planned approach to solution, discuss the results, and then conclusions, and have some questions and answers session. Okay, so the topic is about the mission system, and overall mission systems are a subtopic of allocation of limited resources. Essentially, this task is contributed hugely to the socio-economical part of the country as a whole. And this is the reason why the student university matching algorithms have been introduced in the first place, because otherwise this system is very chaotic, and it resulted in so-called authors racing. So the students at the universities tried to compete with each other to propose at the earliest time possible, and the result, the matching algorithms were wrong. What the optimal algorithm needs to have is take into account preferences of the both sides, and also the limitations imposed by the problem, which is a very important part of why the algorithms are still being developed, because every single unique situation has their own limitations. And all of the work is actually about limitations and how to overcome them. So motivation to do this work is obviously the huge impact that it has on the entire educational system and the future of every person, because assigning just one person only leads to the whole chain of events. So how he, for example, cannot finish his education, or the place is wasted, or for example, he will try to get admitted in the next year. So all of that causes the future instabilities in the future years. And also, as a context in mission system in Ukraine, it was not studied extensively in algorithmical point of view, but it is based on algorithm. It is based on the mathematical foundation, and it needs to be studied because Ukrainian system has several interesting points, including demographical picture that is changing. We have student shortage coming, and we also have some obviously funds shortage. We need to be as effective as possible. And another motivation is that there is no really unified discussion about how to set the success of the system, how do we measure it. So the research goals of this is to model the entire system algorithmically, to analyze every single part that is possibly not even yet discussed as an algorithm, to create an evaluation framework, so to either to use the well-defined metrics or suggest our own. In fact, Ukrainian system has already some well-discussed metrics. For example, often which is used is the percentage of students who get recommended as first priority. In 2025, it was 60%. In our work, we are trying to adapt it. And also, obviously, to profaneness, this is the biggest impact that we estimate in this work, and my biggest motivation was coming into this work to do a project that will have a real impact. So we would like to propose some impactful changes which will improve the admission results. So a little bit about the related work. So a lot of the related algorithms in education in other domains is based on the Gale-Shapley algorithm. So what it is it's called deferred acceptance algorithm. It was developed back in 1962, but so far, even now, every single year, different approaches for it are developed. The reason for that is that it is really well studied and has several useful properties. For example, which we'll discuss a bit later. Another one is serial executive algorithm. It is not really used in terms of admission, but why it is important is that it follows the top rank applicants, and algorithms like these are usually used to accentuate the top applicants. For example, where it can be important is some organ transplantations are the problems where we have that it is crucial to get to the top result because it is, has life-changing performance. Interesting thing that this algorithm is actually fair if the ranking is fair, which is we'll see in a moment. So obviously the most important thing is matching constraints. In Ukraine, it is common law quotas, which is pretty unique for the system. And the problem is that the stable matching may not exist with either person. Stable matching is essentially that no other, which is more complex than that, but that no student prefers any different matching to the current one. And some matching with adjustable bounds can have stable results. For example, if we not have the high measure, but it can change during the some circumstances. One of the useful things here is that low and common quotas are frequently used in other systems also. For example, in Japan, we have regional quotas. In Hungary, we have lower quotas. So we can actually reuse some insights and try some things. Also, algorithm needs to be optimal. So it is usually student optimal and actually university worst in case of Ukrainian algorithm. This is actually the point that proves theoretical that we need external evaluation, because if it is used, if only one side has influence, then the algorithm cannot be manipulated. This is an important result. Key for it is the truthful reporting. How to ensure it is, it's a bit an open question. Essentially, the whole system needs to build trust so that the applicants report truthfully how they behave, but it is not really true for now in the Ukrainian system, which we will another topic. Also about there is some point about fairness. Fairness solution is still a point of discussion, but the most important point to discuss is obviously ability not to be manipulated, and is most often measured by strategy proofness. The metrics, the numerical metrics are not often really used for this because of the lack of data. Some research gaps already mentioned that in Ukrainian context, low quotas, wide contests are not really studied, which needs to be formalized, and also the no unified set of metrics, especially for the data-driven approaches, because data for the most part for the most countries is not really available. In Ukraine, there are also some we have some issues with how they're anonymized, with how some of the fields are not really available publicly. But it is possible to measure a lot of things with data, which actually the metrics are one of the goals for this study. So we don't really have not only to develop the approach, but also to how to measure it, which is an interesting point. Research questions are again, what are the big points, how we can identify them, how the particular algorithm, so particular part of the algorithm is susceptible for manipulation, and how the various groups of applicants, for example, applicants who go to the private to the public universities or the background can change their admission status. Also, the point that we would like to address is the ranking itself fair? Because in Ukraine, a lot of discussion is centered about how we do rank participants based on their external evaluation results. It is not really a point of discussion for any other algorithm, because often we assume that the ranking itself is fair and it is final, so it is adequately formulated. This is the question that is will be the rapid point of our research here. So the blunt approach is first to find balance in the system, so analyze all of the small parts like scoring methods, tiebreakers, ranking rebalancing, which is needed in case of the program closures. And also some special categories of applicants, like, for example, people who get affected by the war and any other categories, which is also discussion about them currently. What is the influence of the mentioned constraints? So we measure those. Then we perform full simulation of the system, preferably with the real data. We develop test numerical metrics. They are a lot of them are found in literature, but as I said, they're not universal. and develop algorithm improvements. We can either develop our own or test classical approaches, and also we can look what other countries are doing. Actually, one of the biggest improvements, which is currently the most important topic, is the 2024 improvements, which prove that the private places can be distributed the same way the public ones do, and this was the biggest improvement. If not for it, it would be probably the biggest result of this work. So what are the risks? The low probability risk that the algorithm is fully optimal. We have nothing to optimize. Actually, that is not already not fully true, because we found some things about it. But this is the point where we can find that some results of the optimization is not really doing a lot of work. So how we can approach it? We can suggest new approaches which can optimize it even further. So even if it is fair, for example, in some sense, we can look at how it can perform, for example, when there will be less students in a few years. Then metrics do not agree. We just show that the metrics have some special properties. This was pretty common for some of the papers that we reviewed, that the metrics can show that something is fair, but sometimes it shows what's the result. And also high probability that full data is not available. We are working with obtaining the full data set. It is almost complete, but this is still a risk that we don't have full data for that. The early results that the ambitious system is fully normalized. We prepared a technical report which is still in draft stage but can be accessed. Already the system is described as an algorithm there. All of the parts are including those that are not really algorithmized yet. They're just in the forms of different documents. Also, the simulation was already created. So far, it was fully run on the synthetic data at the time of this exposé anyway. But we can see that, for example, for this student, which has quota, he has an option to do an interview and not get his external relations course. We can see that he got excluded from these four options, but on this one he got accepted, and this option is still pending. So this demonstrates how the results can be of the algorithm for a single applicant. Each priority here represents, these ones are the priorities for each program, and these are the special priorities for his interview quota. So how he gets accepted if he goes through the special process, and then if he doesn't get accepted here, he participates in the general contest. Yes, so another result is that we are looking into simultaneous program closure. So this is an example of how two programs that will be closed with less than two participants, each of them had one, but if we close simultaneously, both are closed. But if we close only this one, this still has one applicant here, so it will actually have two students right now, and it will not be closed, it will be moved. This is the point of the algorithm that we are looking into as the point to improve actually. So to put conclusions, we outlined the project of how we should perform the analytics into the educational system, identified main research gaps, so the lower quotas, wider common quotas, and put them into our research focus, also with the metrics. We have outlined approach to data collection, so we use aggregated open data, and we have a lot of discussions of how to use them best and how to actually use them in a better way. But we have obtained the opportunity to do so. That is really complementary, so we will not be relying on the simulation data here. First results are already achieved, so algorithm is fully described, initial points allocated, and simulation is already created, and we run it from examples. It will actually help in identifying the gaps that we've pointed here. So the goal is with this, the next steps are to fully compose the real data and to use it to create the full simulation, which will be that we will then try another approaches. So thank you for listening. It's just really interesting time talking about this, and I invite your questions. Thank you.
Thank you. You've been advised. Okay, I will start with my question, if you don't mind. Please. Could you please tell us a few words about the synthetic data you used for starting the simulations?
Yes.
What is the volume? What is the balance? What is the diversity? What is...
Yes, so to generate synthetic data, we looked at the distribution, the real distribution of students. So how their scores are distributed, how their priorities distributed actually. So for example, how many priorities the student give in his applications. Also their quota distributions. And then we either scaled it or used the numbers close to the initial distribution. So the point was to, if we do not using the real data, we're using the exact same points of interest for each program. So for example, there will be some top students which will go to the top universities and so on. Also, the distribution, we looked into how many students applied per program. And the actual applications were distributed the same as in the real applications. For example, 5 applications per student for the top universities or something like that, per place, sorry. So essentially that's what that.
So my second question is about the method you use for simulating this process. This is the process simulations first, understand.
Yeah. So
or you just simulate the final result distribution.
We both simulate the distribution, so for the synthetic data, obviously, and then we simulate all the steps of the algorithm, how it performs. So we develop first we develop the algorithm for this target, and then we developed an extension and coded every part of it and simulated it in this way. So
you just try to determine this algorithm which assigns the items from here to this.
Yes.
To the candidates.
Yes.
So
the goal of this is to essentially to measure it. So to create option to use metrics on it. So we will have the final results. We will have all this stuff, and we then can measure its performance on every step and go to the final, which is actually what is interesting for us.
And this is the bridge to my third question. Well, in fact, you are solving a discrete optimization task problem, if you wish. What is the goal function?
I think the function is well, it depends on the metric, obviously, which we will try to optimize here. But the function is the maximum satisfaction, taking the maximum satisfaction of the student, and essentially how much of the students get to their top priorities.
So you maximize the satisfaction.
Yes, there is options of how to choose it. I also about choosing like the probability of how a student is probable to get his top choice, and also assigning some scoring to the priorities of how they get assigned. So these are actually some of the metrics that we are already using right now in the simulation.
So my fourth question, no more questions so far? Then my fourth question is a bit provocative. What is novel in the approach you're trying to sell us?
Novel is the actual suggestions. So the novelty in all these algorithms is how they adapted to the constraints. For example, obviously the whole algorithm is based on the classical scale-shaped algorithm, but all the complications that are waiting on it from the Ukrainian perspective, like quotas, special places, common quotas, they're not studied, especially together. So we have some studies for over quotas, for example, as far back as 2010, but they in completely another context. In general, for example, there was a paper analyzing the Hungarian system, which a lot of our initial looks and tricks were based on. So long-term approach is trying to fit the Ukrainian context onto the already established algorithms and to draw some conclusions from it.
Okay, thank you. Are there any more questions? No. Thank you very much. So, our next speaker is Kostiantyn Lelikov, supported by Oleksii Zhenchuk. The title is Detecting AI-Generated Ukrainian Academic Text. Hello, Oleksii.
Good afternoon.
The floor is yours.
Thank you. So, thank you for the introduction, and as being said, our work is related to hybrid multi-class classification approach to generated Ukrainian text and working it. And my supervisor is Oleksii Zhenchuk, which I want my knowledge to for help and support you on this project. So, just a second. Here's our plan for today. So, we want to define what is the motivation of doing this work and what is the problem statement, how we construct a data set, and some of analytics of pre-post GPT era, which I explain later, detection approach we used, and hybrid ensembles, which is the key idea here. So, what is the motivation of doing this work? Since introduction of ChatGPT, it's raised like academical concerns and discussion about the quality of students' work regarding that now it can be generated using large language model. And we want to define how acceptable AI infection of the text is for the final result and how we could detect it. The major problem in the scope is that most of the benchmarks that are acceptable, that are available in the web is English-centric or non-Ukrainian-centric, I would say. And most of detection is binary, which is by the fact not like commonly used scenario for AI detection. Like most of the students using AI as a spectrum for generating some paragraph, rewriting some text, and etc. So the goal is outline the levels of AI involvement and find a way to detect. And since there is no benchmark, we decided to build our own, and we followed the regional worker Benjamin and define 5 authorship levels of AI-generated text. First one is a human, and two extreme classes is a human and full AI, and we defined medium saturated classes like light AI, medium AI, and heavy AI, which is by fact is adjusting original text paragraphs to follow this percentage distribution to be rewritten by AI. So about the data we used, we decided to use like academical papers of Ukrainian students that were varied from 15 different universities in Ukraine. University was chosen by the size and like diversity regarding land. So like from Kharkiv and Lviv. Then we used OpenRHEV initiative for metadata protocol, which is supported by the most of the facts all of those Ukrainian university repositories. We query metadata of the original work and the link of the PDF that then was converted to the text. By result, we are having 6,500 records. Split it by pre-22, post-22, so introduction of ChatGPT. There were several problems. Because the law in Ukraine that enforce universities to post works online is pretty recent. Some of the begun jobs, like earlier jobs, are poorly scanned or just missing. So we tried to introduce OCR for that, but OCR produced a lot of noise because of the tables, because of the columnar papers and all the stuff. So since it hurts our quality so much, we decided to skip this step and used only text-based PDFs. Pre-post GPT era analysis. We have an idea that after introduction of ChatGPT, the impact of the ChatGPT affected, not the ChatGPT 11 affected papers can be measurable. And we define several statistical constraints to test our texts. And I will not go through one to another, but in general, we see that most impactful is style related and structure related metrics and vocabulary related metrics are barely touched. About data generation, we decided to use most known commercial LLMs, which is several flavors of ChatGPT, Claude, and Gemini, because the idea is to use actually used LLMs by students, and if technical student can support like hosting on them Mistral or something, most of the students in other university are used just commercially available. So the choice are pretty clear. Then we normalize the text because we run several iteration of this text procedure, and first time it's produced a lot of artifacts related to Markdown and related to some structural obvious markers. So we do data generation several times and then normalize the text by aligning line face, removing line breaks, artifacts, and so on. The final dataset we made consists of half of the human-generated text and half of several level adjusted labels. And here is our detection approaches. We defined several ways to try to detect. One is statistical baseline, which was described as pre-post analysis. We used those observations to build a statistical baseline. Then fine-tune transformers, obviously. Ghostbuster approach, which is kind of state-of-the-art for current text detection or binary text detection. And the most recent methods like some subtext level of the whole document, which is detected independently and then contributes to the final score, which in our case paragraph level detection. And then build a hybrid ensemble of those metrics to see how each of them contributes to the final result. Here is the statistical features, which is based on findings pre-post analysis error, and some of them manually selected. Also, we decided to try adding some more feature, but our results showed that those features are making more noisy inputs that meaningful results. Also, the key observation, which is asked me in my review of the paper, is why we don't use normalized type-to-token ratio, and we define it as written on this slide. So basically, we try to understand, is demonization actually giving the signal of a AI-generated text? And we found out that AI tends to overproduce different forms of word than actual human written text. Then we defined several BERT model. I will not go from one to another and say that the best one is Roberto Lelikov Ukrainian fine-tuned model. I think it's because of cross-lingual transfer from English embeddings to Ukrainian embeddings at the start. And as a continuation of this work, we decided to fine-tune some of the Ukrainian LLMs to see how they produce in the final scope. This is a hybrid architecture of our detector. So basically, we using tuples to combine all parameters and then evaluate it. Like statistical feature, parameter level feature, Ghostbuster results, and Roberto results. And here is so far results of the test. So the best one is the latest iteration of hybrid detector that use paragraph level features, Ghostbuster level features, and this Roberto model. And
The model is pretty capable of detecting binary texts, but tends to fail on the intermediate classes. And the main scope of the future work is to understand what is the problem and define the solution to improve our accuracy in medium classes. So the key achievement of the work is building first AI Ukrainian detection benchmark and evaluation of different existing approaches to detect this text, as well as building hybrid and serial approach. And next time define it here. So we want to try sentence relevance to the paragraph level detector and try to fine tune our large language model and penalize distant misqualifications. Thank you for attention. I open to question.
Thank you. Oh, you're welcome. With your questions? Yes, please.
Do you expect like any bias towards non-Ukrainian speakers?
It's a common problem with English detectors because English is most commonly used language, but on Ukrainian space, it's not critical for us. I would say not in the first iteration of the spot because like this uncommon issue when non-Ukrainian speaking person writing some academic writing. I would say we are not focusing on this. No?
Yes, also.
Will you make your datasets public as a benchmark with Ukrainian language?
Yes, I will, because it was like ethical concern about how we could publish like other people works to the
Makes
benchmark,
sense.
but there is a normalization step which is removing all named entities like names, locations, and all this information that like intimate information for a human. So I believe at least we will publish how to reproduce it, how to build your own data set, but Mango, we will probably publish a data set benchmark as well.
And all the source documents are publicly available.
Yes, so that's not an issue. Those documents, thank you for clarification, those documents are queried from university repositories that are free to use.
Okay. Do you consider for speech engineering like some labels which are used for by model providers to labels that some text was generated?
I had this idea, but in general, the main idea of this work to build like unstateful like detectors, which is not require knowing of base generator of the data. Because Buster works like this, so it actually generates n-grams by detector, which is used, and then use these labels to predict AI-generated text, use this data set.
Okay, from a research question point of view, it makes sense.
What?
It makes sense from a research point of view because you are focusing on the text. Okay.
More questions? I have some. Let's go back to
Sure.
the description of your data set, distribution of different levels of use of AI. Yeah. How do you know? How do you know that here you have full AI use, and here you have heavy AI use, and here you have the rest?
It's
Here it is clear there was no AI capable of. And what about that?
It's my generated part of the data set, so I know when I generated. Maybe I asked the question.
This is
Yeah, this half is generated by myself. So
and this stuff has been
yeah,
inputted from the repository.
Yeah, from repository, and the main idea is before 2022. So we do not use after text because it can be saturated with the text. So
that was understood.
How do you generate it? Because I guess the part of synthetic data creation, which means which models, which protocol prompts here. Is it rewriting or creation of new content?
It's depends on a class actually how it's generated, because full AI was generated by giving original title of the human text and summarization of the work done in this text, and medium classes were generated by rewriting several percentage of the paragraphs using commercial LLMs. So basically it kept some human parts, and depending on the class it generates new text, paraphrasing it. There are several prompts that were randomly selected like in the process of generation, but one of them is paraphrase, and one of them will enhance this like paragraph, enrich with terminology, fix the problems and all this stuff. Basically, we define paragraphs level of the paper, and
I would recommend in your work in detail explain how you did it, say appendix or prompts. That's just a comment.
Sure. I just have one more question about the generation. For example, here, where did you take the title and the abstract? From this, where did you take the title and an abstract to prompt into the generator? From here?
yes.
Is it a correct thing to do?
It seems so. Like we need an idea that will not be biased or very distinct from the original paper scope, so we decided
I'm not sure about that. Just because if you do it from here, then you implicitly compare the generated text with that text. And it's an easier task to solve.
yes.
If you would have taken it from the portion of the archives after 2022, where you guarantee that you have no documents from that period here, that it might be a more fair thing.
Yeah, it's a good suggestion.
It could be nice to compare the files generated from using titles and abstracts taken from this part and from that missing part. What would be the difference there?
Yep, good idea. Thank you. We'll take a look at it.
Any more questions? No? Thank you very much. Our next speaker is Severyn-Dmytro Peleshko with talk entitled Automated Facial Skin Recognition and Skin Analysis of the System.
Yes, thanks very much.
George, yours, please go ahead.
Thank you. One more. So hello everyone again. My name is Severyn Peleshko, and today I want to present my work on the automated facial skin analysis system. My supervisor who guided me throughout all this journey is Elizaveta Kudin. So our agenda today is the next. We will start with the motivation and problem. Then we will go shortly about related work and existing approaches. Afterwards, we will speak about project main objectives and hypotheses with vision of solution. Afterwards, we'll speak more about technicals and some early results, and finally summarize the whole work and speak about our plan of research. So I think all of us understand that facial skin condition it is a very important indicator of person's health and well-being. In particular, even some small acne or pimples, which sometimes arise on our face, can be caused by some serious problems with our body organs, in particular with the liver. But however, some reliable and comprehensive assessments require professional expertise and specialized equipment, which makes them expensive and not widely adopted. Therefore, there is a gap and the need for some automated solution which will incorporate some deep learning technologies. But unfortunately, most of them have some limitations. Many solutions, they simply focus on some single attributes, for example, acne, wrinkles, or redness, and without providing a comprehensive analysis. Some of them might capture more wider spread of features, but are limited to some lighting conditions or skin tone diversity. Therefore, those factors actually create a motivation for a system which will solve these problems. And this we are doing in this work. So speaking about related work approaches, we can divide them in three main groups. This classical CV approaches, where we mainly work with different color spaces and channel thresholding. For example, very popular is CLAP color space. For example, it's a channel. It has a high correlation with hemoglobin level in our blood. Therefore, we can use it for detection of different acne or redness. For some wrinkles or age detections, you can use Kani, Sobol, or Gabor filters. Those approaches are quite fast, but they are very sensitive to our initial conditions, in particular to elimination. Therefore, we need some good preprocessing pipeline initial. Then we have CNN-based models, which actually are strong baseline within the sphere. For example, we can use different ResNet model, efficient net models for different skin lash and segment classification tasks. However, when we speak about pixel level segmentation, there comes into play unit-like architectures. Those models, they provide good accuracy and efficient inference, but also there are enhancements in the deep learning sphere. It is vision transformer models, which actually outperform traditional CNN-based models, but of course with higher latency, because those models are more complicated, they require more computational resources because they use self-attention mechanisms. And in order to address this issue, there arose hybrid models, in particular YOLO modification, this efficient multi-scale YOLO, which combines attention mechanisms, CNN-based features, and low latency inference. Now let's speak shortly about our project main objective and its hypothesis. So as I said before, the main objective is to develop a multi-attribute facial skin analysis system, which will be invariant to elimination condition and skin tone diversity. The system will provide a comprehensive assessment of person's skin face. And in order to use it, we will cover three main facial features categories. The features with the highest priority, groups with wrinkles and acne with redness. The last group with slightly lower priority, it is skin-related features such as texture and tone evenness. So we will find out whether they have some irregularities or not. Speaking about hypotheses, the first it is whether some additional normalization pipeline, including elimination normalization, will help us to improve the accuracy and robustness of our deep learning models. The second one is about that different skin features will differently be sensitive to our preprocessing. In particular, some color-based features like redness and acne might be more benefit from some polar normalization relative to texture ones, such as wrinkles. The third one, it is about model architecture more. It is about that one huge unified multitask model will underperform relative to single models developed separately for each of those categories due to task interference. And the last two are more about facial features, in particular their visual view and their localization. So the fourth, it is about some features actually they share similar patterns and have similar regional localizations. Here I'm talking about acne and redness. Therefore, it may be challenging to distinguish them efficiently. And the last one is that different facial regions have different importance in terms of our target feature. For example, let's speak about wrinkles. So we know that they are mainly localized in our forehead. Therefore, if we pass to the model the whole image of person's face with some background, this can be slightly overwhelming. maybe not very efficient because it can take model's attention from the target regions to some others, for example, cheeks, mouth, and nose. Now let's shortly speak about our regional solution by which we will accomplish our goals. So we will have such pipeline. So we take input some image under different lighting conditions and skin tone. Then we pre-process it and detect our features. More in detail, we will speak about those steps at the next slides. And finally, in order to provide this assessment about which I was talking before, we calculate the score. The score, it ranges from 0 to 1. With 0, it means poor condition, when 1 is excellent condition. Its formula is depicted on the slide, so actually we subtract from 1 the weighted sum. This sum consists of two main terms. It is normalized severity coefficients, which we calculate separately for each condition, for acne, for wrinkles, and so on. Those coefficients are calculated based on the lesion size and its intensity. In order to evaluate it, we will actually measure the detected mask size and work with pixel intensity within it. Therefore, it is very important for us to take away from the image effect of lighting in order to we can more appropriately calculate this pixel intensity. Also, those coefficients will be multiplied by importance weights. Why is this done? Because not all features have the same importance for customers. In particular, those which are easily visible, for example, acne and redness, they have much higher weights, will have higher weights, while those which are related more to some global appearance, such as texture irregularities, will have moderate weights, and those related to aging, for example, wrinkles, will have the least weights. Now let's speak more in detail about our approach. So it consists of 3 main steps. About the last we already scoring, we already spoken. Let's pay more attention to pre-processing and feature detection. So our pre-process pipeline will consist of 3 main steps. First is elimination correction. Here we will employ clash normalization and gamma adjustment. Also, as we spoken before, it is a good practice to pass to the model only the target region. Within the photo, therefore, we will employ region extraction step using face mesh, landmarks, and finally data augmentations in order to improve make our dataset more rich. Our baseline will consist mainly completely consist of classical CV approaches. For wrinkles, it will be Kani and Gabor edge detectors. For acne and redness, it will be conversion to Celeb polar space with channel thresholding. So as I mentioned before, channel A it is highly correlated with those features like acne and redness. The skin tone evenness we will estimate using variance in our color channels, also slab space and texture irregularities. This will be responses of our Gabor filters and Laplacian variance. After establishing baselines, we will work with deep learning models. In particular, for wrinkles, we see this task as a segmentation, so we will employ some net-based architectures. Its model can be joined with some other. For example, it is one of the options. It is to use as an encoder part some efficient net for trained model within the SUNET. And for acne and redness, it will be object detection tasks. So we will employ some detection models, YOLO and SBIT modifications. In particular, those hybrid models, which we discussed before. And finally, it will be more complex models, more heavy models, visual transformers with self-attention mechanisms. Also, I want to show you some of my results, in particular, how work is this image normalization and what effect it has on our images. Here you can see some of our photos within dataset for wrinkle detection. So what we see, we converted our photo to Celeb polar space and took only L channel, which stays for luminance. So here it is the original image, it's L channel of the Celeb polar space. So we see some girl, she doesn't have some prominent skin issues on the face, but actually in the region of the cheeks and nose, they're present. She has some freckles and pimples, but after we apply this cluster normalization, histogram equalization, we actually saw that those regions within cheeks and nose become more better, more visible. Therefore, it improves our visibility of imperfection skins, skin imperfections. So actually, in those normalization which we showed before, we integrated it in our baseline approach for wrinkle detection, where we used a simple UNet model without any modifications. But with this cluster normalization through Ceylon polar space and with some data augmentation techniques, actually it allowed us to increase our performance. In particular, speaking in terms of our early results, we obtained dice score 0.5 for this wrinkle test set. So it actually has a profound effect on our results. Speaking shortly about our research plan, so actually we finished the literature review and problem design and data exploration stages. Also, we developed for each of our categories some baseline models. I haven't showed all of the results in this presentation because it's slightly out of the scope of the proposal paper. And till now, to ends of the April, we are working with experiments, in particular with more complex deep learning models with different more complex augmentation techniques, in particular bidirectional copy-paste, where we can work with unlabeled data in order to produce more efficient and robust models. And also it will be evaluation of results and documentation. So summarizing the whole presentation, our goal is multi-attribute facial skin analysis system, robust to lighting and skin tone diversity, because as you saw, there isn't such solution which will cover main face features, which will provide the final assessment of its quality. Our status is we define problems, develop baseline methods. Now we are working with experiment scaling and documentation of the results. Also from the important observation at this stage was that the preprocessing actually plays a crucial role. It allows us to better to highlight some regions which have those problems, but are not visible due to elimination artifacts. So as outcome, we will have a system capable of assessing overall skin condition and detecting various skin issues, which we discussed before. Thanks for your attention. If you have a question, you're welcome.
Questions, please? Please go ahead. I have no idea what to ask. Yeah, yes, please.
I have a question about personal data. Like this whole this research requires a lot of facial data, which is quite personal data. So do you somehow or is there some cleanup, or what is the whole process around this?
Yes, it is a good question. Actually, one of the problems which we encountered during this during our work is that actually there is very few data sets in open source which contain good labels with diversity of different races, different conditions of those skin imperfection, because even those acne, it can have different stages from very bad to some moderate stages. Therefore, because many companies, they are commercial and those data sets are private, so we don't have to them any access. But some of them are in the public access and they are under licenses in order to provide the security for people who are from whom those data sets were collected. And this.
Thank you.
I'm not super expert in CD, but as I know, there are a lot of state-of-the-art models, for example, for segmentation. Meta provided segment enhancing models 3, also for older versions there are medical segment enhancing models. Give you benchmark some kinds of models to compare with your solution?
Yes, that's a good question. Actually, we explored those sort of models within this sphere, but we haven't tested it by ourselves. But there are papers which explore the limitations of those models, and one of the main benefits of this work is this, that we will try to cover the main facial features, because models which are existing now, they cover some of them, but when we try to combine them, for example, we take some retrained model on ImageNet which good at segmentation of wrinkles, and say it finds some acne or redness on our facial photo. Its accuracy drops slightly. Therefore, we haven't proven this by ourselves, but we actually use those studies which was made before us.
Okay. Also, on the first slide, when you mentioned augmentation techniques that you will use, I see there are classic augmentation techniques. It's totally fine. Do you consider any like synthetic data creation, for example, using diffusion models? I guess it might help, like to generate some skin problem. I guess.
Yes, thank you. This is a good question. Actually, some of the data sets which we are already using, they are synthetic already, because as I mentioned, due to some safe issues which we already discussed, there is a few good data sets in the public access. Therefore, some of them are already synthetic. About data augmentations, yes, here is some more quite common use baseline augmentations. But now we are also exploring some more complicated ones, in particular this bidirectional copy paste. This is when we, for example, we have two data sets, one with good labels and another it is much higher, but we don't have any labels. This simply photos of acne or some redness problems within person's face. And the logic is behind them is that we took some part of the first data set, took some part of the data set without labels, combined them, receive this synthetic image. Also, it has some sub-labels which we also combine in this generated image. And this allows us to provide model with more rich information. And by combining those photos within one image, those parts of different data sets, we slightly mix their data distribution, because each of them has its own, and it can be not very good for our model. Therefore, those bidirectional augmentation techniques allows us to somehow overcome.
Okay.
Thank you.
Thank you.
Unfortunately, I do not have time to offer you more questions. So thank you. Our last speaker for today is Andrii Potopa, backed up by Mykola Babiak. The title of this talk is Intraday Regime Switching, Decision Layer under Transaction Costs. For it's yours. Looking forward.
Good afternoon, everyone. My name is Andrii Potopa. I'm a student of Ukrainian University. My supervisor is Dr. Mykola Babiak from Lancaster University Management School. Today's talk is about detecting intraday market regimes from time series images and using those regimes
to make trading decisions that explicitly account for transaction costs. First of all, I like to say sorry about my voice. I'm a little bit ill today, so here is the roadmap for today. We will move from motivation, why regime detection matters at all. Sorry, through the problem formulation and the proposed approach to each experimental results and next steps. Let me talk about what is financial market regimes. To be short, in different times, the market behaves in fundamentally different ways with respect to volatility, liquidity, and infrastructure. The critical point is that those switches happen with a single trading session over minutes, not days. A model trained in a calm regime degrades sharply as soon as the market enters a chaotic one. And now the first key climb of our work. Most research pipelines in this area stop at computing the so-called regime probability vector. PT equals the probability of ZT given the data. In other words, the system says with 80% accuracy probability, we are currently in the regime, let it be number 2, and that's it where it ends. But we are not evaluated on regime detection accuracy. We are evaluated on how much money the trading strategy earns or loses after all costs are deducted. And especially in intraday trading, costs are not a footnote. Every position change includes a bid-ask spread, broker commissions, and price slippage. If the system constantly waffles, flipping between regimes back and forth, it destroys itself through transaction costs, even if each individual signal was correct. This is why we need an explicit decision layer with so-called dead band region, switch only when the expected gain clearly exceeds the costs of switching. And that is the central scientific contribution of this thesis. Let me talk about what has been done before us. The literature contains a large body of work on regime detection. It's a hidden Markov model, Bayesian online change point detector, and different neural network-based detectors. Detection quality is measured quite well. It's a label accuracy, area under curve, and both of one score widely used. Sorry. But if you ask what happened to the actual strategy return when deployed on live data, there are few answers. Probability calibration, action stability under transaction costs, integration of multiple signals, all of this remains on the periphery. This is exactly the gap we aim to fill, the decision layer as the primary object of study, not just the detector itself. Next slide is about research gap. If we had to formulate this as a single question, it would be how exactly should stochastic regime beliefs, uncertainty measures, and change point evidence be converted into trading decisions with explicit transaction costs? This sounds like a system design question, but behind it lies a serious theoretical and empirical problem. There is no well-established validation protocol and no clear understanding of which quality of teacher the underlying regime detector leads to good student the trading strategies.
And this is our scientific target. Problem setting, let us formalize the problem. At each moment t with the trading session, we observe a feature vector xt, prices, trading volumes, and proxy measures of volatility. The market is in a hidden latent regime zt, which takes value from 1 to k. The detector outputs a probability vector of pt. Trading frictions of is formalized in a CT of WT minus 1, and WT is greater than or equal to 0. The cost of transaction from the previous position weight WT minus 1 to the new weight WT. In our formulation, this is a linear function of the position change multiplied by the round trip spread. Note that CT equals 0 if and only if the position doesn't change, which creates an economic incentive for processes. It is worth explaining that data we work with. We use 5-minute so-called OHLCV bars, the standard format for exchange data. Each bar contains opening price, the high, the low, the closing price, and the trading volume over a 5-minute interval. With the New York Stock Exchange trading session lasting 6.5 hours, this gives exactly 78 bars per day. We work with 4 assets. Two of them are primary. It's SPY and QQQ tickers. These are exchange traded funds, so-called ETFs. SPY tracks the S&P 500 index, the 500 largest US companies. QQQ tracks the NASDAQ 100, top 100 technology companies like Apple, Microsoft, NVIDIA, and so on. We additionally consider ETF IWM. It's a small capitalization fund, and the XLF, which covers the financial sector. The time range is from 2020 to 2026. The key point of formulation is a strict no look ahead constraint. No parameter and no decision may be made using data that would not have been available in real time. Next slide is about research questions. From this formulation follow 4 specific research questions with corresponding hypotheses. First, does a decision layer with a hysteresis, so-called dead band region, reduce the number of position switches and improves the final share ratio? Second, does probability calibration improve system reliability and reduce signal chatter? And third, does the regime change signal B prime T reduce detection latency and drawdowns? Fourth, the next one, how robust is the system to inaccurate cost estimates? If we misspecify the parameters, does everything break? Each hypothesis will be tested on real data throughout a rigorous cross-validation procedure. Proposed pipeline. Let us look at the diagram. The input in raw 5-minute bars. They feed into the belief source, either a hidden Markov model or a convolutional neural network operating on Gramian angular fields images, which will be described on the next slides. The output is a probability vector PT lying in the probability simplex. The next block is calibration. Neural network and hidden Markov models often produce overconfident probabilities. The network says, for example, 95% probability, but the true hit rate at the threshold is only 70%. We use temperature scaling, a simple technique. Divide the logits, the raw network outputs before softmax by temperature parameter T greater than 0, and then apply softmax again. Next slide is a description of Gramian angular fields and interaction with convolutional neural networks. The key technique idea is how we convert a time series into an image. You can look at three-panel figure. The left panel is simply the raw price series for a single trading day. It's SPY on 7th of April 2020, comprising 78 5-minute bars. And this is the ordinary time series. And the next tool is a representation of this time series in images, Gramian angular fields. And why is this representation is so useful? Because the matrix G represented encoded pairwise interactions among all 78 times steps simultaneously. Transactions, and opening and closing patterns all become spatial texture. And convolutional neural network, unlike, for example, LSTM, sees this entire structure as a single image rather than a sequence of points. And according as I said earlier, the 78 bars, it's one whole trading day. So in this image, convolutional neural network sees entire trading day. The right panel shows the same construction applied to realized volatility. It's squared returns. In total, we have 4 channels per trading session. The return graph, Gramian angular field, the volatility graph, and the volume graph, and the sinusoidal time of a day function. So the network knows where it is looking at the open or close of the session, and it's important, and I will explain it, why later. This 78 times 4 image are fed into a convolutional neural network. The architecture consists of 4 convolutional layers, global average pooling, and K equals 5 outputs with softmax. Approximately 102,000 parameters. The network learns from a teacher. The regime labeling produced by HMM or another method. Later I will talk about that. I used several of them. Next slide. Evaluation plan. The table of this slide describes our ablation matrix. A systematic comparison of pipeline components. Rows corresponds to pipeline components. The first is the belief source, row PT versus calibrated P tilde T. We measure expected calibration error, the average deviation of stated probabilities from the true frequencies. The second is the regime change signal with and without B prime T. We examine detection latency and drawdowns, the economical measures. The third is decision layer, a single threshold versus the hysteresis-based one. And we measure the number of position switches and the average holding time. The fourth is cost sensitivity. We run the system under different assumptions about spreads and trade commissions. The fifth is belief source, hidden Markov model versus Kremlin angular field plus convolutional neural network. We compare not only accuracy but the downstream quality of actions. Our protocol is strict. Walk forward false, calibration and decision parameters are tuned only on validation data, and the results are read of the test period only. Next, let me talk about current progress. The progress table, the first two stages are fully completed. Data have been downloaded and processed. Cross-validation splits have been formed. The hidden Markov model has been trained, and the B'-T model is fully operational. The next three stages are actively underway. Gramian angular fields image generation and convolutional neural network training, post-hoc calibration, and development of the extended decision layer. And the final two are pending. The full relation and the thesis write-up are still planned. This slide shows the results of the first two stages along with the figures of the on the right. You can look at the right-hand figure. It's a diagram of our walk-forward cross-validation procedure. The time runs left to right. Each fold is an expanding window. The training gets grows, and the validation and test periods shift forward. In total, there are 10 folds covering 2020 from 2020 to 2026. This approach.
We have 1 minute left, together with the question time.
Sorry.
Please transit to your conclusions.
I'm sorry. I wanted to talk more about the results, but the results of
sorry for interrupting you.
Yeah.
All of you had the same time slot.
Let me talk about opening questions and shortly about expected contribution. There are opening questions that will define the next phase of our work. The first one is which teacher produced the most useful student, and second, does better calibration actually reduce action chatter? And this needs to be verified quantitatively rather than taken as an axiom. And the third, how should the coupling strength of B'-T be tuned depending on the asset and the regime, a single constant or adaptive scheme? Expected contribution, what we plan to contribute to the in the result of this work. First is a decision-oriented evaluation protocol, systematic way to compare regime detectors, not by accuracy, but by the quality of trading actions, net of transaction costs. And second, an empirical comparison of belief sources via downstream quality, rather than in statistic metrics. Third, and interpretable decision layer, featuring calibration, hysteresis, and B'-T gating. And also fourth one, an understanding of when regime beliefs become actionable at all under trading friction. And not this is not a trivial question whose answer with this work is we're planning to provide. Next steps, concrete next steps planned to the coming months. It's complete the full ablation matrix, conduct strict holdout testing on the remaining folds, and fix all parameters and run only on tested data. Complete the cost sensitivity analysis, finalize case studies on specific regime change events. Thank you for your attention. You feel free to-
Thank you very much. Unfortunately, we don't have time for questions. Sorry about that.
So, sorry.
So this finishes our last session for today. I will be happy to see all of you tomorrow for inspiring sections on computer vision. Have a nice rest of the day. Hopefully, some of you will wish to join us.
Yes, actually, not hopefully, but we invite everyone to join us social event. Yeah.
When and where?
Yes, so let me. So